Hello, we have already discussed Ohm's law and solved several problems on Ohm's law. And last time also we discussed some issues that usually students find it difficult to understand. Now we'll discuss in the basic Ohm's law circuit how the voltmeter and ammeter are connected, and from those reading we calculate the resistance. What is the accuracy of the resistance calculation? Let us for example let us just recall our Ohm's law circuit. This is the resistance, and this is the resistance of value R. We have to calculate its resistance. Then how we can calculate from the Ohm's law? R is equal to V divided by I. If you have forgotten this, then you can recall the Ohm's law triangle. That is V at the top, this is I, this is R. V is equal to IR, I is equal to V divided by R, or R is equal to V divided by I. So from this formula we can calculate the resistance. So measuring the voltage across the resistance and the current flowing through the resistance, we can calculate resistance R. Suppose this is the voltmeter that we connect across the resistance, and ammeter is connected. It may be connected here, or it may be connected also here. If it is connected here, then this is the circuit, and if it is connected here instead of connecting here, then this will be the circuit. So these are the two alternatives by which we can calculate the voltage and current that is flowing through the resistance. But here we will compare to which method is good for which method is better for our resistance calculation. Let us consider first this circuit. Here the ammeter is connected like this, and voltmeter here across the resistance. The resistance R is that Rm, that is the resistance that is calculated by measuring the voltage and current, that is equal to V. V is the voltage across this resistance divided by I. I is this current, that is V is the what this voltmeter is showing, that is the voltage across the resistance, and I is the current that this ammeter is showing. Okay, that is, you can see that here the voltmeter reading is all right, that is taking the voltage across the resistance, but this ammeter, it is measuring the current of current that is flowing through this resistance, that is suppose IR, and also the small current that is flowing through this voltmeter, let this be IV. Now this IV is usually very less, very small, because this voltmeter is having very high resistance, and the voltmeter resistance is usually of the order of some mega ohm. Let it may be 1 mega ohm for our example. And if this resistance R is small enough, suppose R is nearly or less than 100 ohm. Okay. Suppose R is less than 100 ohm, then what you will see here, the current flowing through this resistance will be very, very large than the current flowing through this IV. So this current IV is negligible, that you can see that if it is 1 mega ohm and this resistance is 100 ohm, or suppose 10 ohm, 15 ohm, then you can see that this current will be very less, and this current will be IR will be 1000 times of IV. So it can be, this current can be neglected. Actually voltmeters are also taking some current, otherwise how this equipment will operate, how this device will operate. Okay, so here we can replace this current I by IV plus IR, that is IV plus IR. This is the actual current it is measuring, but our resistance is R is actually, that is equal to voltage across this V divided by IR. This is the actual resistance, but we cannot measure this. We are measuring here. If we will measure this plus the ammeter here, then it will be this circuit. That we will discuss. So you can see that this is the actual resistance, what we are measuring this. As I said, this IV is very low, then IR, then this IV will be ignored, that is nearly 0. So this becomes V divided by this becomes V divided by IR. That is very this value depends on the value of resistance. Okay, because if R will be comparable to this voltmeter resistance, then considerable quantity of current will flow through this, then this is not easily ignorable. In that case what will happen? There will be a big error. But if this resistance is small enough, there will be very little error, or you can say that there is no error. Okay, so this method is good for small value of resistance R. One thing is that before analyzing this, you should be thorough about the series parallel connection that we discussed some time back. So you should go through that also, otherwise you cannot understand this. Okay, and last time in one video we solved the parallel circuit. This is 1 ohm and this is 100 ohm, and the current flowing through this is 100 times of current flowing through this. Similar case here, it is 1 mega ohm and it is 100 ohm, 100 or less, or maybe some 500, 1000 like this. So in that case, this resistance is very small in comparison to this resistance, and the formula is alright. By measuring this voltmeter and ammeter reading, we can calculate this. So we can say that this V by I is almost equal to V divided by IR. Okay, that is V by IR is the actual resistance. So Rm and R are almost the same value. But if this resistance will be more, then this value will differ much from this value, and more error will be introduced. Okay, so this is good for small resistance, small resistance value. And let us consider this one. Here ammeter is connected here, so voltmeter will be, one terminal of voltmeter will be connected here and other here. Now you can see that in the previous what happened, the voltmeter was giving the actual voltage across the resistance, and ammeter is not giving the actual resistance, that some current is flowing through this. It is measuring both this current and this current. Here you can see that the current flowing through the resistance, that is accurately measured by this ammeter. Let this current is IR, and this current is IV. Here you can see that this current is accurately measured, and this is not giving the voltage across the resistance. In addition to the voltage across the resistance, it is also taking the voltage across the ammeter. Let this voltage is VA, and this voltage is VR. VR is the voltage across the resistance and VA is the voltage across the ammeter. Okay, now what we are calculating the resistance Rm, that is equal to how much? Rm here is equal to this voltmeter reading. We are calculating this from the reading, from this reading. Okay, that is equal to V divided by this current IR. Okay, that what we are calculating from this readings. We are taking the voltmeter reading, we are taking the ammeter reading, dividing, and we are calculating this resistance. Okay, but actual case, let us remove this. But actually the resistance is how much? But actually the resistance, that is R, that is equal to VR divided by IR. In this case, what you saw, that voltage is okay, but the current is not the current what is flowing through the resistance. And in this case, the current that is flowing through the resistance is alright, this is okay, but the voltage is not the voltage across the resistance. That is the main thing. But Ohms law states that R is equal to V divided by I, that is the voltage across the resistance divided by current through the resistance. Here in the measurement we are getting the current that is flowing through the resistance, but voltage across the resistance we are unable to measure, and we are taking the voltage across the resistance plus voltage across the ammeter. So Rm is equal to V is now VR, VA plus VR divided by IR. IR is alright, and VA, what is VA? It should be VR divided by IR, but this component is coming, and if this resistance of the ammeter will be very small in comparison to this resistance, then there will be very little voltage drop. If suppose this, usually the ammeter resistance is low, that may be around 1 ohm, so it may, if it is 1 kilo ohm, that means 1000 ohm, then this voltage will be 1000 times of this voltage. So this voltage you can easily ignore. Okay, so in that case VA is almost negligible, that is, so Rm that becomes VR divided by IR, what we should get. Okay, so this will be almost same as the resistance. This Rm and R will be the same. But if this ammeter resistance will be comparable to this, suppose it is 10 ohm and it is 100 ohm, then this voltage will be, VA will be 10% of this, then there in this calculation there will be much error. So it is not good for low resistance calculation, and it is good for high resistance calculation. Okay, so this is for high resistance value. So this arrangement is for small resistance calculation, and this is for high resistance calculation. That's all for now, and we will discuss more next time.